Linux is good. Okay, let's talk about physical AI. Speaking of Linux, let's talk about physical AI. So, physical AI. Imagine, whereas your large language model, you give it your context, your prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is, this model in the middle is quite large, has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token. So you could have hundreds of thousands of tokens, and the computational load increases quadratically. And it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we needed Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective, computationally demanding. What if instead of PDFs, it's your surrounding? And what if instead of the prompt, a question, it's a request? Go over there and pick up that, that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics. And the technology is right around the corner. But what we need to do is we need to create the effectively the world model of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. If you drop something, it falls to the ground. If you, poke at it, it tips over. It has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball didn't leave into another quantum universe. That's still there. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create we need a world foundation model. Today we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance, even across multi-sensor views. Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
NVIDIA Cosmos. NVIDIA Cosmos. NVIDIA Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands moving, manipulating things, things that are fast camera movements. It's really about teaching the AI, not about generating creative content, but teaching the AI to understand the physical world. And with this physical AI, there are many downstream things that we could do as a result. We could do synthetic data generation to train models. We could distill it and turn it into effectively the beginnings of a robotics model. You could have it generate multiple physically based, physically plausible scenarios of the future, basically do a Doctor Strange. You could, because this model understands the physical world, of course, you saw a whole bunch of images generated. This model understanding the physical world, it also could do, of course, captioning. And so it could take videos, caption it incredibly well, and that captioning and the video could be used to train large language models, multimodality large language models. And so you could use this technology to use this foundation model to train robots, as well as large language models. And so this is the NVIDIA Cosmos. The platform has an autoregressive model for real-time applications, has diffusion model for very high-quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world, and a data pipeline so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end-to-end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open and available on GitHub. We hope